We have so far learned about the technologies in the computer networking. We'll talk about Open System Interconnection Model in this video, OSI model, which is a very important in the computer networking and for the data purpose as well. So that is a basic, but for this we have to learn the basic networking concepts which we have already covered in the previous videos. You can watch in the playlist computer networking. So welcome to DOS Tech new video, and we'll talk about OSI model in this video now. What is the OSI model? The Open System Interconnection OSI model is a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocols. In plain English, the OSI provides a standard for different computer systems to be able to communicate with each other. The OSI model can be seen as a universal language for computer networking. It is based on the concept of splitting up a communication system into 7 abstract layers. Each one is stacked upon the last. Each layer of the OSI model handles a specific job and communicates with the layers above and below itself. DDoS attack targets specific layers of a network connection. Application layer attacks target layer 7 and protocol layer attacks target layers 3 and 4. What are the 7 layers of the OSI model? The 7 abstract layers of the OSI model can be defined from top to bottom. So 7, the application layer. The application layer, this is the only layer that directly interacts with data from the user. Software applications like web browsers and email clients rely on the application layer to initiate communications. But it should be made clear that client software applications are not part of the application layer. Rather, the application layer is responsible for the protocols and data manipulation that the software relies on the present meaningful data to the user. Application layer protocols include HTTP as well as SMTP. Simple Mail Transfer Protocol is one of the protocols that enables email communications. Sixth, the presentation layer. This layer is primarily responsible for preparing data so that it can be used by the application layer. In other words, layer 7 makes the data presentable for applications to consume. The presentation layer is responsible for translation, encryption, and compression of the data. Two communication devices communicating may be using different encoding methods. So layer 6 is responsible for translating incoming data into a syntax that the application layer of the receiving device can understand. If the devices are communicating over an encrypted connection, layer 6 is responsible for adding the encryption on the sender's end as well as decoding the encryption on the receiver's end so that it can be represent the application layer with unencrypted readable data. Finally, the presentation layer is also responsible for compressing data it receives from the application layer before delivering it to layer 5. This helps improve the speed and efficiency of communication by minimizing the amount of data that will be transferred. Fifth, the session layer. This is the layer responsible for opening and closing communication between the two devices. The time between when the communication is opened and closed is known as the session. The session layer ensures that the session stays open long enough to transfer all the data being exchanged and then promptly closes the session in order to avoid wasting resources. The session layer also synchronizing the data transfer with checkpoints. For example, if a 100 megabyte file is being transferred, the session layer could set a checkpoint every 5 megabytes. In the case of a disconnect or a crash after 52 megabytes have been transferred, the session could be resumed from the last checkpoint, meaning only 50 more megabytes of data need to be transferred. Without the checkpoints, the entire transfer would have to begin again from scratch. For the transport layer. Layer 4 is responsible for end-to-end communication between the two devices. This includes taking data from the session layer and breaking it up into chunks called segments before sending it to layer 3. The transport layer on the receiving device is responsible for reassembling the segments into data the session layer can consume. The transport layer is also responsible for flow control and error control. Flow control determines an optimal speed of transmission to ensure that a sender with a fast connection doesn't overwhelm a receiver with a slow connection. The transport layer performs error control on the receiving end by ensuring that the data received is complete and requesting a retransmission if it isn't. Transport layer protocol includes the Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). Third, the network layer. The network layer is responsible for facilitating data transfer between two different networks. If the two devices communicating are on the same network, then the network layer is unnecessary. The network layer breaks up segments from the transport layer into smaller units called packets on the sender's device and reassembling these packets on the receiving device. The network layer also finds the best physical path for the data to reach its destination. This is known as routing. Network layer protocol includes IP and the Internet Control Message Protocol (ICMP), the Internet Group Message Protocol (IGMP), and the IPsec suite. Second, the data link layer. The data link layer is very similar to the network layer, except the data link layer facilitates the data transfer between two devices on the same network. The data link layer takes packets from the network layer and breaks them into smaller pieces called frames. Like the network layer, the data link layer is also responsible for flow control and error control in the intra-network communication. The transport layer only does flow control and error control for inter-network communications. First, the physical layer. This layer includes the physical equipment involved in the data transfer, such as the cables and switches. This is also the layer where the data gets converted into a bit stream, which is a string of ones and zeros. The physical layer of both devices must also agree on a single convention so that the ones can be distinguished from the zeros on the both devices. Common security attacks in the OSI layer model. 7 application exploit, 6 presentation phishing, 5 session hijacking, XSS attacks, session side jacking, malware, 4 transport, reconnaissance, TOS, TCP session hijack, fragile, sync flood, LAN attack. Third, network, man in the middle, smurf attack, ping of death, teardrop. Second, data link, spoofing, MAC spoofing, MAC flooding, VLAN hopping. First, physical, sniffing. Thank you for watching.